Okay, so we are going to look at AI evaluation today. And then the other thing we'll also do is to build the RAG, right? And pull all we have done together into, actual real world scenarios. So, but we'll first of all look at what evaluation means. If you remember last week, we looked at observability. Observability is just a word that means being able to analyze and observe what is going on. And I think I showed example of that with Langsmith. In fact, I'm going to just open up my Langsmith account. Oh, okay. It wasn't on this computer that I had a Langsmith account. Sorry, not on this browser. Let me open the other one. But yeah, without spending too much time, we were able to uh, open up Langsmith, create an account. Then from the Langsmith account, you get API keys and the URL, and we'll put it as environment variables, right, in your LangChain. Once you do that, that's on Python anyway. Once you do that, then Langsmith picks up. However, with JavaScript, it's not that seamless. So I'm going to do a bunch of examples on JavaScript also for the benefit of the JavaScript folks, so that you'll be able to see how you could also get Langsmith. So we'll do that during the hands-on. So we looked at that observability, and you can see it was very easy once you connect um any API, any call you make using a LangChain function, either agentic call or chains or prompts or whatever, right? Automatically gets logged or um traced. Tracing is just a process where whatever is going on is being tracked. And when there is a fault, you can actually, or an error, you can actually trace down to where it comes from. Right. So today we look at evaluation. So what is evaluation? One of the most important aspects of AI in deployment or in service is evaluation. Evaluation is where you are able to look at um, you know, your AI product or your AI agent that you have built, right? And you are able to say it is doing well or it is not doing well. It is a systematic process of measuring how well your AI system performs on specific tasks. So you actually have to define the task, right? And so it's kind of a representative thing. You may not be able to evaluate everything, right? But you will be able to at least um, evaluate how it performs on that specific example that you have pulled together. So evaluation actually requires you pulling together examples, which you then test. Just think of it like writing test coverage, basically, for normal stuff. That's really what evaluation is. But there are certain, it's not this exactly same as test coverage in the sense that you're not really testing the code itself, but you're testing the responses that the um, LLM gives to you. So interestingly, in a typical AI application that you write, you will have both test coverage and evaluation. The test coverage is to ensure that your code is well written. And the interesting thing is that you will end up mocking a bunch of things, especially calls that you call out to the API and so on. In test coverage, you're going to mock those. But in evaluation, you're not going to really test the code. You're actually going to test the behavior, the input that goes to the LLMs and the output that it goes back. So there is no mocking in that case because you're testing the system as it is. So we use both quantitative metrics and qualitative metrics. Then we have what we call human in the loop, right? Or model-based assessments. So these are all different types of evaluations. We are going to see some of them. It is critical to determine if a model is reliable. That's the main reason why we do evaluation. You need to know if it is reliable, if it is safe to deploy, whether it has biases or not, right? So you have metrics that we use. You can check for accuracy. Accuracy is how close it is to the truth, at least based on the data it has or you've given to it. Um, with respect to how the agent responds. Okay. Then hallucination rates. You know that hallucination is when the LLM begins to come up with things that are not, the real thing, simply because, for some reason it is not able to, or maybe it was not trained on that data. So it begins to generate very wrong, totally off point information. Okay. Then safety is the LLM itself being able to recognize when the responses it gives may cause harm and therefore is able to detect that and not respond in such situations. Then operational efficiency, you know, how efficient is LLM in giving its responses. So when you do evaluation, what you're trying to find out is one, is the answer correct, right? That's accuracy. Two, is it grounded in the retrieved document or knowledge, right? And that has to do with hallucination rates and so on. Is it helpful? That's UX. So the types of evaluation you could do, you have automated evaluation where you are also using another LLM to judge, the outcome, the results. So that's an example, LLM as a judge. We'll also look at that. Then you have a heuristic. So heuristic is because these answers are dynamic, so you cannot really write a set of evaluations or tests that will say, okay, for this question, this is the exact answer I check, unless you are using another LLM to judge that one, which is the first option. But if you're not doing that, you cannot really write hard-coded, evaluation to say the answer must be exactly this, right? In that case, um, you could use heuristics. For example, check the length of the response, check citations and things like that. Then, of course, the other type of evaluation is using a human in the loop kind of evaluation where you bring in human beings, um, basically crowdsource the evaluation. So a good example of that is to have a rating user interface so that human beings can actually check. As human beings are interacting with your agent, they can then rate the responses, whether they are helpful or not, whether they are useful or whether they are dangerous and all of that. Then you also have a regression type of evaluation. There's a regression type of evaluation. That regression type of evaluation is where, you compare the output with output from a previous iteration where maybe it had already you had previously stored the previous evaluation of this same agent, and then you do another evaluation, and then you compare those two to see which one has changed, or whether it has changed, whether it has gotten worse, uh, or not, right? So that is regression. Okay, so some of the key aspects of AI evaluation, you have quantitative metrics. So this one is like standard. This is typically how you would, um, you know, do evaluation of any model, right? Using the quantitative metrics for modeling AI. This includes precision, recall. You have F1 score, which is a combination of precision and recall, and then things like accuracy and latency. So these are all things that you will use for normal model analysis, right? Normal model analysis, right? Um, this is something that you see in machine learning, ML. Okay, so that is quantitative metrics. But you also have qualitative assessments. So qualitative assessment is where you are checking um, the actual outcome or results from the AI, right? Review to see whether, the outputs, you look at the nuance, look at the tone, you look at relevance and things like that. Okay. So that is qualitative assessment. So those are some of the kinds of metrics that you would use when you are doing evaluation. So the types of evaluation you have the offline evaluation. So offline evaluation basically is where you are testing the model during development. So the model has not been deployed yet. Okay. Um, you are testing it during development. You're using fixed data sets to compare against benchmark. So I'm going to show some examples of that. So the fixed data set is you can give it questions, you can give it tasks and all of that, right? And then for each task, you can also put out what you expect to be a reasonable answer that should be coming back from that LLM. Okay. And what you now do is when you run, you check and confirm if that works or not. Okay. So that is offline evaluation. So typically this just means you're evaluating in a development mode. You are not evaluating when the LLM or agent is running. Okay. Then online or real-time evaluation is evaluation that you do while the agent is running online. People are using it. So in that situation, what you are doing is that you are monitoring the live data that is coming in and out. And then based on that live data that is coming in and out, you use it to track performance drift or user satisfaction. So we are going to see how we do both of them. So some of the key metrics that you will look at would be hallucination rate, like I said. So hallucination rate measures a frequency of false or fabricated information. Okay. Like we said, hallucination is when the LLM begins to fabricate information. It's not grounded in truth. It's not grounded in real data. Okay. So that's hallucination rate. Accuracy is when you are measuring correctness against the ground truth. So it is actually giving you information that is correct, but how correct is it? Then safety and bias checks. So this is another kind of metric which ensures that the model does not produce harmful or prejudice content. So what this means basically is that you are trying to check whether the content or the responses that the model gives is making sense or whether there's biases in that content. Okay, so those are some of the metrics that we will use. Then we also look at context. So in which context are you doing evaluation? So you can do evaluation in the context of the LLM, right? In this case, you are checking if you are just checking only the LLM itself. Remember, in an agent, you have different components. Well, you have three main components. The first component is the LLM, which is a reasoning engine. Then you have the um, tools, right, which gives the agent the ability to do things. Then you have the reasoning process itself, right? They react and so on. Okay, so that reasoning loop. So when you are doing evaluation, you can decide to just evaluate the LLM, to evaluate its reasoning, to evaluate its generation and summarization capabilities. That's one context. But you can also evaluate the agent as a whole, which would include the ability of the agent to use the tools that are given to it and to reason, right, based on the response or results that come back from the tools, and then also the react loop or the plan execute loop, all of those loops, the ability to complete multi-step tasks. So the AI agent context is where you are essentially evaluating the entire thing, not just the individual components. Okay, so we are going to do a few examples of how to do offline evaluation, and then we'll also do examples of online. But take note that for online, the process is normally um, you, the user makes a request, the model gives a response. So you are going to actually log the request and also the response from the agent after you run the agent. So you log the inputs, the request, and then you log the response, and then you log a timestamp. Okay. And this log is later what you will use. You can store it in a database, in a file, or somewhere. And then you will later on, outside of the normal life cycle, you will then pull those logs and use those logs to run eval on those logs. So basically, it's as if you are taking the logs as new data that you will use to eval the the uh, the agent, and then you put it on the dashboard. So of course, the logs themselves also provide you information, which you can take the response, for example, to check how that response, how close it is to what is expected, and so on. Then we will use one of the approaches, the agent evaluation, which is we are looking at tool usage and so on. So these are the examples. So at the end of the day, we'll come back to talk about this, but when you are deploying an entire stack, this is typically just a summary of how it is, okay? Front end, we'll call the back end, which in this case, we're using Fast API with LangServe, okay? Then the LangServe basically is a Fast API. It builds on top of Fast API. Then you can then have your AI agent or RAG chains or whatever running, okay? And then, of course, the agent and RAG is essentially LLMs using tools and storing in memory. And then you can implement tracing with Langsmith, and then evaluation, where you do both offline and online. So these are some of the metrics for you to track when you're doing evaluation. Latency. Latency is important because you want to know how well your model is able to satisfy the user's needs. That's why latency is about user experience. If the latency is too long, it means it takes too long for users to get responses. A lot of your users may actually abandon your app for that reason. The other thing is token usage. So that's another thing you want to monitor. Sometimes you may have to optimize your agent to minimize token usage. And there are many ways to do that, including things like rewriting your prompts, okay? Looking at your tool calls, reducing the amount of tools that you load, basically optimizing tools that are loaded to the agent. Um, we talked about that a little bit some time ago where we said, okay, you are not going to load all the tools that you have into an agent call because it's not all those tools that may be relevant to that particular request. So you can actually use another LLM to determine which tools should be loaded, and then you only load those tools, right? Not all of them. So that matters. Tool calls, yes, affects behavior. Okay, so you also have to check how well your tools are written, how well your tool calls are written. How do they handle exceptional situations, errors, timeouts, delays, um, you know, um, intermittent or temporary failures or outages, and so on. Then retrieval hits is important. Retrieval hits tells you like how grounded is your agent in information. If the retrieval is not very good, then your agent will not be able to give very good information, right? Or even do the right things. So that deals with your retrieval. Then the val score itself, which is ultimately the total measure of the quality of your agent. So those are the things to take note of. Okay, so there are a few things we'll look at, but let's just go check out some things. So we'll start with the first hands-on, which is just doing basic offline evaluation. So I'm going to switch to my I have let's switch. Okay, so I have in my code space, I have a code space where we were doing the LangServe example. I also use that opportunity to open Langsmith, smith.langchain.com. So that's the Langsmith account. Let me log in. All right. So yeah, so we have that Langsmith is up. I go to the app so I can open the app here. You can see the app here. The last time anything happened was 6 days ago, so I've not really touched it, of course, since the last class. But yes, you will see that we still have a bunch of queries. It's still tracking stuff, right? The things I did. I actually did a bunch of other stuff. Um, so now the code space is running. Yeah, the code space is running. Okay, so we're going to do a little bit of evaluations. So LangChain has a bunch of evaluation. Um, so we're going to do basic evaluation of um, an endpoint. So remember last week I had written an endpoint. Um, Let me show you what we did then. I did a basic endpoint for this agent, all right, where the agent itself, let me show you the tools. We have the model and the LLM, and then we have the tools. So if you look at get tools, the tools have calculator and search nodes, right? Calculator just does any calculation, and the search nodes does um, that. So we are going to, yeah, let me run this right now. Even though I've made a bunch of new changes, so I might have some errors here, but let's start by loading the virtual environment. Okay, then I'll run UVCon. Um, app dot main. Well, another way, I think main also has, okay, it doesn't have that. So I'll just run, you've got app.main, app, right? And let's add reload. Okay, so this is going to start our server on this port. So remember, if you are, yes, I was expecting this. So I'm going to comment out this section. That part of the code is not yet completed. I didn't have time to complete it, so I will just comment those out. And we just focus on the agent part. And yeah, so it is running now. And you see it's running on port 8000. So what I need to do is go to this ports tab and enable the port, make it public so that I can access it from outside. So port 8000, I just right click on it, change port visibility to public. Okay. So it takes a bit of a while. It has to stop that port and restart it. Then you'll see that it has an address here that I can access. So I just click on this to copy the address. And then I'll open a new tab and just paste it. So the good thing with Fast API is that it gives us an interface we can actually play with the API, what we call Swagger. So of course, GitHub gives us this error. Sorry, not error, a warning, just to let us know that somebody's using code space to build something. So you should be sure of what you are doing. Well, we are sure what we are doing. So yeah, normally you have to put a /docs for you to get the documentation in a Fast API endpoint. So of course you see that we have agent. All of these are generated by langserve, like I showed last week. So you have the invoke and the batch and the stream. These are the ones that really matter yeah, these ones are for input and output schema. This is if you want to build apps that can explore, or you want to use this as an MCP server. So basically, langserve also allows you to build MCP servers, which means that other AI tools can query your input schema, output schema, config schema to know what your endpoint is capable of doing, or what your backend rather is capable of doing. So, but for now, we'll just use the basic invoke, right? To invoke that. So if you can see, there's nothing here. Maybe I can clear this, but I will not. Let me just leave it. This is stuff I did last week. So again, you can invoke the agent and pass a bunch of messages, right? Specify the content and type, right? So for now, I'll only just do one message. The type is not going to be AI, it's going to be human message. Human, right? Now, let me remove all the others. Okay. So this has to be valid JSON. So I hope everyone here you have handled JSON, so it should not be too difficult. This is just how information is exchanged, right? I don't need to specify config hash. It is not required. So I just run this, execute. My Langsmith is also running. And this is all we did last week. The you can even go to Langsmith, and I need to refresh this. Okay. So it actually gives an output, and the content um, is string. This is what I sent. Its response. The content is also empty. So let me see if there's any type is AI, any tool calls. So it sends a tool call. I just because I just say content string, so it didn't know what to do with that. So it's called a tool call, and the tool call gets run, right? It asks for this tool call search nodes query string. So it's going to search if there is anything, right? And um, the content from the tool call, this is a tool call response. It says use retrieval chain for this query. And that goes back to our AI, and our AI processes that and still does another tool call. And that's why it took a bit of time anyway. Search not string ID is this. So this continues in a loop. I searched the internal nodes for string and found following information. Let me know if you like to explore this further. I need additional details. So, well, the reasoning loop stops there. Okay, so now let's do a little bit of evaluation. So I've just brought my stuff up. Um, we can write code for evaluation. We don't actually need to do an API call for the evaluation. I guess I was just testing this. While we can leave that running, but we don't really need. What we will do is write evaluation code. So here I have already started. Okay. So we are not going to use the RAG chain, rather we are going to use the agent. Okay, so we'll get the agent. And we are going to import. So we will pull in the agent. Now, evaluator, by the way, this is how we used to have it in previous LangChain, right? We used to have this LangChain evaluation load evaluator. So we just use this approach. But a lot of these evaluation methods have now been moved to Langsmith. So you can use Langsmith to do evaluation as well, right? And I'm going to show you how we do that shortly. But let's just look at this. So you have an evaluator. Load evaluator is a function that allows you to load any evaluator type, okay, from this evaluation module. And so we choose this particular type called QA, right? And then the criteria that we want to check is correctness and helpfulness. So we give examples here. So we have one example, and then we have a reference. So the reference is like what what our LLM, when we're evaluating the LLM, we'll evaluate against this answer. We have evaluate against this answer, right? Which is basically saying if the answer is close to this, give it a good score or something like that. So let me now add another one. So remember our agent has if you look at this, our agent has two tools, which we have here in the tools. It has a calculator tool and a search notes tool. So if we look at the, okay, hold on, let me change this file because we actually have, we should have two separate evaluations, one for the agent and one for the RAG. So this I will call evaluate agent. So the RAG one, we'll use it for evaluating the RAG. Let me remove all the RAG stuff here. Okay. So, so let's add a query with calculation. What is the square root of one and oh well, okay. Let me just go with that, right? So we now have reference. The reference is the answer that we expect. Reference the square root of okay, this is 167. Yes. So that is the reference. Now I need to double check this. So I'm going to pull up calculator. We could actually do this in Python right here. So I can just run Python and then square root of sqrt of 167. Yes, this is the same problem we had. So this is the same thing that the LLM did. Square root of this 0.5. Not square root, sorry. 167 raised to power 0. So 12.92. Interesting. So our agent, our coding agent was even able to figure that out. All right. So we can add a bunch of other questions, right? So that's examples that we want to use for the evaluation. Okay. Right. Because you have a question, go ahead.
Yes, sir. I was looking at the import lines. I saw where you imported from app.agent, get agent. So I was wondering that is it from this one of these files here?
Yes, it is
The
in this
function.
app.agent. It's in here, this agent file. I'd already defined it
Okay.
last week,
Okay.
right? This is just a helper function that you can use to create an agent, right? So it's just a helper
Yes, I
function.
get it now.
Or you could
Thank
have
you.
just done it directly. Okay, um so you can put in whatever examples you want to put in, okay, to use for your evaluation. So you can now see that the code that I use for the evaluation, I am basically just saying for each example in these examples, we will run that example through the agent, right? Agent.invoke. We don't actually use run anymore. So we will do agents.invoke and we will pass in messages. So we have to pass in messages as the input. So it's typically going to be a dictionary with messages. Yes. And then these messages will be a list. And one of them, we can make it a human message or whatever. Okay. We could actually do it. We could just stack the message in. I think it will pick it up. Or we could be more elaborate and specify type, role is human, content is this. The same way we have been doing it. So, yeah, then when you get that uh, prediction, which is actually a list. So let's just say results, result of the agent call. Okay. Um, so the prediction is result, the last result is actually the last result. So remember, an agent invoke gives you a list of messages, just like what we saw here when we were running it. It's going to give you back a list of messages and a structured response. Okay. So if you look at this, this is a typical response. So the last response, you can get the content from it. That's the standard that LangChain uses now. So for us to get the last response, we use result -1, and then we we get the content of that. Okay. Let me just check if that's a dictionary or structured data. Um, it is a dictionary. So yeah, so you get the contents from it. All right. So that gives us a prediction. So we'll now take that prediction, okay, and pass it into the evaluator that we created. So remember we've loaded an evaluator. We specified as a QA. Okay, so we can now put it and we ask it to evaluate strings. Okay, so it's just going to compare the string response from your LLM with the reference. So the reference is what you have in your examples here, which basically is not going to be an exact equality comparison, but it's going to kind of how close is it. Then the input, you pass in the input as well, so that the evaluator will use that to know. And then we will now print out, this is a query, this is a prediction, this is the evaluation. So let's just see if we run this. This is a very simple evaluator that will show us all of that. And you can see this evaluator doesn't actually need you to run your API call. So I'm going to stop the UVCon and we just run the evaluator directly. So to run it, you just do Python, right? We just run Python -m app.evaluation dot eval underscore agent. That's how you want to run it as a class, but you could also run it by specifying the route. But I always like calling Python functions this way. Okay, so the first thing we have is that we have a 400 error. So let's see what the issue is. Specify prompt or messages. Okay, so it seems like my invocation call. Yeah, I think I should. Let me see. My invocation call. It says error message input requires specify prompt or messages. Okay, I specified message rather than messages, so that is where that error is from. So let me run it again. So now again, for each example, so we have two examples we will run. Okay, so we have a key error that says -1. Um, so obviously, let's see. I think I have missed something. It should be messages as well. Yes, it should be output messages. The response has output, then messages. So that's what I should have. It has metadata. Okay, so it should be results output first. And then messages. I assume that is what it should be. Or maybe it's just result messages. But let's try it again. Okay, so there is no output in it, which is quite interesting. Um, oh yeah, okay. Yeah, this is from me. Output is, it should be just result messages. Um, the output is added by our endpoint, not by launching. Okay. So the last thing is it should just be dot content. Yes. But let me confirm. It's an AI message. I I did check. It's it's an AI message. Okay. Okay. So let's try it again. Okay. So I'm having a 401. Let's see. So we're having open AI authentication error. Okay, so it looks like I need to specify. When I'm specifying the evaluator, I need to specify which what LLM to use. Because I didn't specify which LLM to use, it's using a basic um yeah, it's using the basic base LLM. So let's just use our own LLM. Yeah, it says agent.model. We could still use that, or we can just get LLM. Well, we can still use the agent's model instead of uh, creating a new one completely. So let's run this and see. Okay. Yeah, yeah, let's just do get, let's get LLM from here. So we can do get LLM and I'll just get this. So let's just use get LLM, app LLM. So let's from app.llm import get LLM. So we will just use that. And I've already configured this to be able to give me open router Nemotron. So we'll still use the open router Nemotron for the evaluator. The interesting thing with setting up this kind of system for yourself is that if you look at my implementation of Get LLM now, I did a little bit of work on this. I set it up in such a way that I have configuration that I can use to determine what kind of LLM I want. If it is OpenAI, GPT-4o LangChain, if it is Open Router, NVIDIA Nemotron, and so on. If it is Grok, it's Llama 3.3. If it is Google Gemini, and so on. So this really supports the swappability. I can create, I can create LLM of, um, different configurations, just by, so it makes things a lot easier. All right, so um, now we have the right LLM. So let's run this again. So this time I expect it to give me the correct evaluations. Yes, so you can see here, it gives me evaluation on the first one. Um, you will see it gives query, what is bug propagation? prediction, blah, 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 all of that. Okay. Then evaluation, reasoning, grade is correct. Value is correct. Score is 1. So this means it is able to compare backpropagation compute gradients to train neural network with what the LLM returns. And the evaluator, by the way, the evaluator is basically just another um, a query that you put together, right? And you share with the LLM, right? You send that query or that prompt to the LLM, and then you send it the reference information and the actual prediction, and let it give you this thing. So you can actually go into LangChain and look at its evaluator and see how they implement it. But at the end of the day, you see that it still boils down to just um, another set of query, another set of prompts rather. So then this one is the second one. What is the square root of 167? And this is a prediction which we compare, right? This was calculated using expression 167, which computes the square root of 167. So again, you can see it is compared with what we gave as a reference, and you can see that. Now let's try something and say, okay, I just want to prove something to see if this LLM knows what, well, just to see what would happen if we had a bad evaluation, for example. So let's add another one and give it, um, okay. Um, well, I don't want Jane Austen. I just want to, I know that the LLM is going to give me Jane Austen, but yes, or maybe I should ask a question that the LLM cannot come up with. So let's say how many um, how many uh, um, um, oil pumps got damaged yesterday, right? Yeah, I'm just going to, there's no way to have this information, right? So um 23. So I'm saying 23. Okay. Now I want to, let me run it. It's actually going to make a tool call to the knowledge base search, but the knowledge base search is not going to give it very useful information. So it's actually the fault of the knowledge base tool, okay? But then we are evaluating the entire agent. So it will fail because since it doesn't have any information about that, okay, it's just going to come up with something. It will definitely hallucinate. So you can see, right? Score is 0. You can see, it actually gives a whole bunch of stuff. Like, I don't have access to specific operational data or logs. Of course, it doesn't. I'm sure it's done a tool call. If you want to check if it did a tool call, you can go to Langsmith, right? You see, I don't need to. Let's see. This needs to give me something recent. Still using the old stuff. Um, Wondering why it's not doing this. It should, but let's see. Yeah, but you see, yes, it does a tool call. So you have this tool call QA eval chain. This is even a tool call to the eval chain, right? But let's look at the actual, yeah, this is the actual LangGraph call, which is the agent call. LangGraph is the agent call, while QA eval chain is the eval call. So in the actual call here, um, you see that there's a to call, right? There's a human, the first question, it does a to call on search notes. Okay. Search note, this is a query, all pump damage yesterday. There is no response. The tool response is use retrieval. The tool is not very useful in this case, right? And you can see that's what we wrote. If you go check our tools, okay, you see what we gave as the response from the tool called search notes. It just a hard-coded string, which is not useful to the AI. So typically in a normal situation, you should actually go to some kind of database or somewhere and see if you can run this query. Okay, or use a RAG, a retrieval augmented system, to look for this information and send it back to the agent. Because you've already told the agent, okay, can find this information, if you want to search the internal, um, database, but it's not giving any useful information. So, the LLM is not able to get a very useful response from the tool call. The response from the tool call gives use retrieval. It tries a second time, right? It tries a second time, it changes the query a little bit, right? Just to see if it will help. And of course, our tool call is still useless, so it's still giving back the same answer. So after two attempts, so you can see there's a retries involved. After two attempts, the reasoning part, the LLM that's doing the reasoning just decides, man, this tool call is not useful to me. So it gives you this response. I don't have access to specific operational data or logs about damaged oil pumps. System indicates that a retrieval chain would be needed to answer this query, but I cannot execute that process without additional context or data sources. Would you like me to help formulate a more specific query or check another type of information? Okay, so that's the response we get. And that response is now of course, that's the same response as this. I don't have access to that. It's basically the same thing. Now, this is taken to the retrieval. Interestingly, you can also see what the retrieval chain is doing here. The retrieval chain also does. So you can even see the query that the retrieval chain is using. You see the input, answer, query, result. I don't have access. Um, I'm interested to know how the internals of the chain, but it's not showing me the internal implementation of a chain, right? Um, but this is the output from the chain. Okay, interesting. I would have thought that Langsmith would allow me like to break down. This is the query and all of that. But since it's a chain, I guess it does not go into the internals of the chain, which is quite interesting. Anyway, so you get that reasoning. This is reasoning, and um, grade is incorrect. Value is incorrect. Score is 0. So this was me just trying to show you that your eval can also catch incorrect values. So this was just trying to test situation where the agent doesn't have access to that information. So even though the agent does well, okay, but in terms of um, answering the question correctly, it didn't do very well. Okay, so you can see that in this case, what we are using is what we call it's agent-based, right? Evaluation. You are using another agent, another LLM rather, um, to evaluate the to compare, right, and come up with the evaluation. There are so many other things you can do, right? But um, we'll not be able to go into all of that. But that is online. Sorry, this is offline. This offline evaluation. So you can see that in this offline evaluation, I have already pre-canned examples. Typically, you could also store these examples externally in another file so that anybody that wants to change it can change it. So I could actually just do this. So I could create um, a file here and just call it eval data.py. Okay, and then we can put it in there. Or even better, if you want to put as a YAML file or you know, um, yeah. So um, eval examples. So this allows you to separate the code, right? So you can import from eval data, import eval examples. And then you just use eval examples here. So that way you don't need to come and play around with this code. Okay, you just do this. So that's online eval. You can also do offline. So to do offline eval, we could use the same eval agent script. The only difference is that we can now extract data at the point of creating or of engaging with the agent. So this is how you would normally do online. We go to the endpoint itself where we've created add routes, right, for the agent. Okay. Now, the interesting thing is LangServe adds the routes and you have invoke, right? So in this case, because we already have this is already built in. Typically, if I were to create my own endpoint, for example, let's assume I created my own endpoint. Let's say get. Let's just do um, agent query. I'm calling it query now. Okay. And right. Yeah. So I just do the same thing. This is the same thing. Okay. But here now, before we would have to store the we can store the result for later evaluation. Okay. So what you would do is you could do something like with yes, yeah, we could just do this. You write. We could use JSON as well. I think I would prefer to use JSON. Um, or CSV, you know, something that's easy to pull. Um, if you wanted to do JSON, you could do something like this. Import. So let's import JSON here first. Okay. So you could open. Let's just say agent responses dot JSON or agent eval data. Let's just call it agent eval data. Okay, we just open it for reading, or we could even just open it for read write. Then we um we load first. So we just load from the file. So that will be data. We just load from the file. Okay. Um, so when you load, and then you append. So after loading, so we, yeah, okay. So there's a whole bunch of other things here, but let's go with this. Okay, so this is, yeah, this is a good way, I guess. So we load existing data first, right? If that existing data, if there's an existing file, we load its contents as JSON. If there's no file, then we just initialize JSON to an empty string. Then we append the current one, right, to this query. So we do data.append the query, the response, okay, which is result messages minus one content, okay, and um, we should also, okay, yeah, just the query and the response, which is what we will use later on for the, for the evaluation. And then after that, we write back, okay. We open again this file for writing, and then we write that back. So this section of the code, right? We are manually basically just storing some of the data. Okay, so later on we will come back and then take this data and run it through evaluation. Okay, that's basically how it is. Now, what it does mean is that our evaluation that we wrote here, this evaluation we wrote here did not actually, it just loaded here, but we could make evaluation that would load. We can modify this to load from the JSON data. So let us now simulate an online, since we have an endpoint now. Okay, I just created this. So this will still exist in addition to the one that LangServe gives me. But I'm going to ignore the LangServe one for now and use this one that we just did. Okay, so let's run UVCon. Okay. App dot main app load. Okay. UVCon doesn't take -m. UVCon doesn't take -m. It just works as is. Okay, so let's check our port again. I need to switch this port back to being public. Okay. Then I copy this link, but I think we already have it here. So all I need to do is refresh, and we'll be able to see the new one. So this agent invoke is the one that LangServe gives to me. But I'm going to go look for mine. So this is the one I created, agent query. This one has the online, pooling of data that you use for evaluation. So in this case, I'm just putting the query. I just made a query, just made it simple. Not trying to match this. So here I can then ask any number of queries you send will get loaded. So the first one is what is artificial intelligence? So I just run this and I should hopefully get a response. It's taking a bit long, so I hope there's no problem. We do have a problem here. Unbound local error. Okay, so the challenge we have is, I don't know what F is. Text IO wrapper. Yeah, and yeah, so this is the failure. Um, yeah, this is wrong. We are just, data is just a list. So there shouldn't be any indent. It should just be a straightforward append. So again, this is what happens when you when you're vibe coding and you're taking LLM input without checking it. So it does sometimes it does crazy things. So really, I'm just appending this to data, which is really supposed to be an object. Okay, and there's no error handling here. I'm not going to bother about it now because I'm not doing production code. I'm just doing some demo. So this has been updated anyway. So let's go back and try. So I'm going to run the same again. Our agent should run and then give me a response. So we now have a response. Artificial intelligence is this, that, that. Now the interesting thing is this worked. It actually saved. It should have saved it somewhere. So you see this agent eval data. If I open it now, you can see that my query is stored here and the response is stored here. So it's just stored and kept. Then later on, I'll use it for evaluation. I can now ask another question. So what is the sum of the squares of two? Okay, let me do something that requires a tool call. What is Pythagoras theorem? Based on this theorem, give me the size of a hypotenuse. Hypotenuse. Can't spell hypotenuse anymore. Hypotenuse. No, that's wrong. This also doesn't look correct. Okay, hypotenuse of
PHE.
that doesn't look correct, but it probably is of a right angle. It's a long time since I finished school. My memory is failing. Okay, triangle with sides 3 and 8. So let's see. I will be interested to see what the two calls come out with. So this requires a two call, but it can give you the theorem without a two call. Okay. So I can be watching Langsmith. Okay, so it's very nice. It gives me response is says a right angle triangle is square, blah blah blah. So that's cool. Some square is style, but mathematics expressed as all of that. For a triangle with size 3 and 8. So first of all, it's able to come up with the numbers. That's the reasoning part of the LLM. I deliberately wrote it in words. Okay. So it now does square root of 3 squared plus 8 squared, which is square root of 9 plus 64 square root of 73, approximately that. Now let's look at the two calls. by checking Langsmith. Okay, so what is Pythagoras? So, okay. So it does a tool call by asking for square root of 73. Of course, that our error, remember what we did there, we throw the error back. So it now does it the correct way and it gets the answer. But interestingly, it did not request for square of 3 and square of 8. It somehow did that on its own, square of 3 and square of 8. Square of 3 is 9, square of 8 is 64. And it was able to also do the addition, the sum, right? 9 plus 64, which is 73. So the only tool call it did was square root of 73, which it doesn't know how to do by itself. So you get 8.544. So that's interesting. So anyway, I just wanted to try something. So if you now check our eval data, you see that the second query has been appended because we built it based on that JSON thing. So this is how you just continue to collect this data. I'm storing it here in JSON file, but you could store it in a database. You can even store it in a RAG. You can store it anyhow you choose, right? So what you now do is you can then take this eval data and based on this eval data, you can then run your eval code. So we don't need to go into details of that because I think we already have an idea. Basically, online eval is like offline, but the only difference is that you are collecting the data online and storing it somewhere. Then at a later time, you come and run offline eval on that data that you collected. So in this case, we are not actually going to call our LLM. We're just going to take this query response and we're going to plug it directly into this evaluator. So we are going to call the evaluator, but instead of, in this case, you see, we are calling the evaluator here after doing the prediction, okay? But instead of calling doing the prediction in real time, we'll just take the results. So this is how you would do that if I wanted to do the offline. Okay, so let me just write that as a separate script, even though it's basically the same script. Yes, let me just copy this. Let's just copy this. Let's say eval agent online. Okay. So there will be a few differences. We are still going to we don't need to get the agent anymore because we are not going to run the agent. But we need the LLM, which is what we will use. We're not going to pull eval data. We'll rather load JSON. So we'll just import JSON. Okay. Then we will now do evaluator equals load evaluator. So here we'll open the agent eval data, which you can see here. So instead of doing any direct, we just open it, we load it from this JSON load. And then in this case, we don't need to invoke, we don't need to run this inference because the inference has been run already in real time. What we just do is to go straight to the prediction, which luckily for us, our smart agent is giving me the stuff I should put in. I don't know if I really need all of this, right? The prediction is directly in the example file, right? Let's see the example file. You have query and response. So prediction is response, reference. Oh, okay. Hold on, we have examples. Yeah, so we can still pull our examples. Yeah. Okay, so let's do this. I forgot, we should still pull our examples because in evaluation, we are still going to compare uh, um, um, evaluation. Yeah, so we are still going to pull this. Okay, so this will be agent eval data. So we will load agent eval data, and then we can actually go now in agent eval data. We can search, right? The reference, we will, yes, this is what I was looking for. So we are going to pull, we will find the reference where the query matches the query from the example. Okay, let me rename this. Let me just call it sample. Okay, so for each sample, you take the response from that sample, and then you also find in our reference examples. Okay, we have our reference examples. In our reference example, you find the one that matches the query. Okay, you find the one that matches the query. And when you find that one in the examples, you get the actual reference. So this is how you get the reference. Then I will return null if nothing is found. So I'll return null. Then I'll only do this and yes, if reference is not none, right? And if it is not none, in other words, if there is, then we do the evaluation. So this is a case of saying, okay, for each of the data that I have pulled, I want to check if there is a sample in my, sorry, I want to check if there is a corresponding question in my eval set, in my evaluation set that matches this question. And if I see that question, then I can do an evaluation on that. So the only issue with this is that I am doing evaluation based on, um, you know, based on only where I already had evaluation data, right? Now, if you look at this, the agent, I have what is artificial intelligence. I also have what is back propagation, but I don't have what is artificial intelligence. So typically that means I will have to go and create, okay? I'll have to go and create eval data that matches. But if I don't have eval data that matches this, then maybe you can fall back to the option of saying, okay, if I don't have eval data that will be able to eval this particular samples I have collected, maybe I can try using an LLM, right? Where you can just say, use LLM to generate reference. So in that case, you can now do the LLM call. So you can just use another agent. That means we will have to create a reference agent. So you could just do something like reference agent equals get agent. Okay. So that's the one that you say LLM as, that's the second one where you're using the LLM as a reference. Okay. All right. So I have a reference agent. So so we use a reference agent and we do that and then we get the content. Then we now run the evaluation against that reference result. Okay, so This is another way. The ref using another LLM to generate the reference result, if you didn't have it already, right, is a very good way to check for regression, especially if the LLM is the same LLM, maybe or an earlier version of that LLM. So there are different things you could do at this point. Okay. You could try so many different things, but at the end of the day, the fact that you are able to access another LLM, right, and use it, that's the one that we call LLM as well. We are using LLM as judge, but we're now using LLM to generate the reference. So the beauty of this approach now is that at least you can actually assess each of them. You can actually access any of them. It doesn't have to be that you are limited because maybe you couldn't get it. So let's run this and see what happens. I'll just do python-m app.eval agent underscore agent. Sorry, app.evaluation dot eval agent online. Okay, so this is just going to read those files and do evaluation. So you first of all use for the ones that you don't have a matching query. In this case, all the two queries that we've had so far in this file are not, they don't match anything. So we are essentially going to, okay, something interesting. I was expecting a response. Oh, yeah. I did not print. I did not print. So I should have printed. So it's actually done the evaluation, but I need to print. Prediction samples. Prediction reference evaluation. No, reference is not sample reference. Reference is reference. Okay, right. So that should be okay. So in this case, this is online. For samples that match our example reference, we'll use the example reference. For samples that don't match, we will use another LLM and to generate the reference. So with this, you can see it gets a score of 1 for the first one and also a score of 1 for the second one. So one of the things that you can do is use different models. You can use a really good model for your reference so that you can always double check. But it's not a good idea to use the same model for both the model that you use in your production, use it as the reference or the one to generate the reference, or use it as the one that is the evaluator, right? Because you may have situation where what we call common mode errors or biases, right? It will basically not, it's like using somebody to judge himself. It's not a good idea. So it's good to use different ones. So this is how you would do it if you were doing it, manually, right? There are other ways, like we said, you could have a human being to do that for you as well. But in that situation, you have to do a front end where the human being can give you some checks. Then you could also use heuristics, right? I'm not really going to use heuristics here, but there are different ways you can use to check. Now, the interesting thing is that Langsmith also does a bit of this for you. So the question is, how do you do evaluation with Langsmith? For this one, we kind of wrote evaluation by ourselves. Okay. But let's see how we can use Langsmith now to do evaluation instead of coding it, because evaluation now kind of exists. So you can see we have tracing, we have monitoring. Okay. So if we were to do monitoring, we would be able to monitor traces. So this is something we didn't really look at last week, right? When we're looking at what you can do with Langsmith. But just looking at your user interface, you can see things like LLM calls, that you've made, LLM latency, right? So latency is how long it takes before your agent is able to give responses. You can see tokens, right? Cost of tokens, output, output tokens, for each trace, input tokens, per trace. So you see a whole bunch of stuff here, right? This gives you shortcuts to go to the same place. Feedback scores. All right. Now, there's something we call the golden data set. The golden data set is basically the data set that you are going to use if you wanted to do your evaluation. So when you open the Langsmith, you have to define evaluators, then run experiments. So you go to datasets and experiments, right? You can first of all create a new dataset. So let's say you can either upload a CSV, right? Or JSON, okay? Or you can create from scratch. So let me just like create a dataset from scratch with a few things that I have. So you know, um, so you create simple testing dataset, name simple testing dataset. Okay. You can have schema. Um, let's see, add property. Well, schemas are nice, right? But I would just want to upload. Maybe I should just upload JSON. Okay, well, let's just create. We can add schema. We can still add schema later on. Schema is good so that you can confirm that the information you're putting in is not it follows, you know, um, that. So we have created data sets. Let's see. After data set, you create evaluator. You create evaluator, then you create experiments. I need to add examples to this. So I can now add an example. Okay, so let's add an example, just direct typing. I don't have any thing, so I'm just going to type stuff in here. I'm going to go borrow from this um example eval data here. So I'll just borrow from this. Now there are three examples. So we'll take it one at a time. So take the first example. We could equally have just uploaded a file, right? So that's cool. Or I can switch to JSON. Let me see if JSON only allows me a single one. So yeah, this looks like JSON. It's actually JSON, so that's okay. A Python dictionary looks like a JSON. So that adds a single input. Um, so the reference output. Um, okay, so I did not specify the reference output. So let's go back. So this is the reference output. I should have added it here. So let's reference output field name. Um, value. Okay, so add that. Okay, all right. So inputs. What is backpropagation? The reference output backpropagation computes gradients. So we kind of have this. Okay. Now I can add a bunch of other ones as well. But yeah, you do that, then we'll do an evaluator. So we can add an evaluator, either from label data from scratch. You can write custom code. You can combine multiple evaluators. So so if you go to custom code, you see examples of code, right? Which if you want to run a simple um, Okay, I had a little glitch. So you add a example, then you add evaluator. So the evaluator, you can create it from label data, or you can create from scratch, or you can write custom code. The custom code allows you to um, basically write your own code, which is like if this, then this. But so the custom code helps to do the heuristics where you could say, okay, let's take some input. If the input matches this particular thing, you basically are writing the code by yourself. So this is for rule-based. But you could also do an evaluator that is a from label data, right? So for you to create an evaluator from labeled data, you have to select experiments for human review, annotate the selected experiments, then create an evaluator prompt and test against expected data. So for you to use um, evaluator, for you to add an evaluator from label data, you have to create experiment first, okay, which we did not yet create an experiment. So the other type of evaluator you can create is a composite score, which will combine that, or you can create from scratch. Okay. So for creating from scratch, you would have to essentially build a rubric. So let's just try by using one of them, which is we create an experiment. Okay. Then when we create an experiment, we will then load some data and then use that data to all right, so let's create an experiment first of all. Okay. All right, so let's create an experiment. We can run in playground. Okay. So we have a test data set here, and then I decide to do a playground. Let me just run a simple human query. So we can say, yeah, so this already kind of builds it. It uses this query which we have created, whatever is in the query. And OpenAI. So let me set up the model. Let me set up a model. Let's see if I can get this from OpenRouter. OpenAI compatible endpoints. Okay, yes. So OpenRouter AI API version 1. Okay, then the model we will use, I will use my usual Nemotron. Let me just pick that up um, from here. Uh, LLM. Let me just pick that up from here. Okay, so, all right. Temperature 0, I'm not going to max stop P frequency. I'll just leave this as it is, JSON mode. All right. So I save this as, let's just call it Tron open router. Or open router Nimotron. Okay. Right. So I have an LLM model configuration tools prompts. Okay. Yeah, so I've picked this as my save this test prompt. Okay. All right. So I've created an evaluator. I've created a sample data set. I've created an evaluator. You're a chatbot. The query is basically this, right? I can answer the question. Okay, now evaluate the response provided using the reference outputs in the data set. Okay. Right. I need API key because of that. I think I have that in my .env. So for the open router. Okay. So there's that here. And okay. I don't know where to save this, but all right. So let's see what this gives. So we already have a rate limit. Uh, okay, this is the key. Maybe I should use Gemini. Or maybe this key is, let's try the second key. Mm. It's possible. Let me just get different one. It's possible that I have um it's possible that model is not available anymore. So let me look for another one. Well, that's the same thing. Okay, so I am getting rate limited. I wonder why I'm getting rate limited here. But if I run my evaluator from here, I'm not getting rate limited. So I wonder why. Maybe it's because I'm doing it from, if I run this, do I get rate limited? Anyway, yeah, I think I'm getting rate limited. Yeah, I'm getting rate limited now. Okay, so anyway, let's see if I can use a different um let's see if we could use Hugging Face since I have exceeded my. I don't know of any other model I can get free models from. Maybe I should try Grok. Uh, DeepSeek. Hmm. Let's say just text, input text, output text, free, DeepSeek. Let's try a different one, DeepSeek. I haven't tried DeepSeek before. Okay. Okay. Probably need to get a new API key. Or maybe I have just been rate limited. Let's see if I can get a new API key. Open router. Let's just get a new API key. Okay, so I need to create an account. I don't have an account on this. Let's try Hugging Face. Models. Next generation. Minimax. Minimax. I don't know if this is free, but Minimax. Okay. Let's try Minimax AI. Let me see if I can get another. I'm going to try another. Um, let's try a different API key. We'll still do even the DeepSeek free didn't work. So I'm trying a new API key. Maybe I've been blocked finally. Uh, yeah, it does look like my particular account has finally hit the limit. Okay, so and we are running out of time. Let's see if I can get it with with Google Gemini. Um, so let's make a new configuration. Okay. Flash. Let's use flashlight. I think I've probably already exceeded my flashlight stuff. Um, Key. I need to get Gemini key. Okay. We had streaming enabled. Okay. So let's run it one last time. Right. Okay. So, okay. So we have query, we have reference outputs, we have outputs. We can now add an evaluator and So this time I just it's easier to use pre-built evaluators. So I'm just going to add pre-built LLM as judge. We need to pass which we're not going to use this. We're going to use still going to set up Google Gemini flashlight as our LLM. Save it. I have to put the key. And check your evaluators. I have one evaluator for correctness, evaluator for hallucination. Basically, we use the same. We'll see use the same Gemini flash lights configuration. So what I have done is add different. Okay. What I've done is we have pre-made evaluators which you add. Then you add your data set. So I've added two evaluators, one for hallucination, one for correctness. And there are a bunch of others which we can add later on. But let's just try how this works. So we have inputs, we have reference, we have outputs, reference outputs, and then we have this. So we can start. So what you now see is that when you start, you have your reference output, you have the actual output, then you have your evaluator that you have set up. So you will see the evaluator for this particular experiment, what is propagation with this reference? Your output, you are getting correctness of 1. But hallucination is giving you an error. So maybe I'll check and see what's going on there. Okay, so context is needed here. So I think you can play around a bit more with this, right? But the main thing is you create an experiment, you create inputs, you create a reference output. The reference output is a data structure, so it has to match. Maybe you can put flat input. I did not put a flat input. All right. So input to structured prompt is missing variables context. So you might need to provide context. So this is basically built with a chain. So you need to put context to the input. Okay. And so each of the different evaluators you put, you have to go check out the documentation for the evaluators to know what you pass in. Because we don't have a lot of time, I can't go into too many examples, but the playground is one way where you can set up evaluations on your, on your backend, your agentic backend. And I think I might actually take some time to give a more, maybe I'll do a separate video just to share with everyone how you can do a more thorough, like if you really wanted to test, you know, your tools or your backend, um, end-to-end setup, right? I'm going to do that so that we can, um, you know, benefit from this and leverage on this Langsmith. So Langsmith is still a new thing, right? There's still a lot that is going on. You can definitely get a lot more benefit from it. So already you can see from that first experiment that we have run, you will see the evaluators that you added. You see values from them here in real time. You can see the correctness. Hallucination is giving us no, that's why we're not getting anything, right? If you do another run, multiple runs, you will see the same. For these other ones, correctness was no, hallucination was no. As at this point, I had not added those evaluators. Then you see latency. So it gives you all of this. You can plug it into your real life data, right? Real time. You can check the evaluators we have added here. You can add more evaluators here, right? And then you can go check your experiments. So I had done my experiment in the playground. That's why you couldn't see it here. You could also set it up as prompt and so on and so forth. So what I would encourage is everyone go play around with Langsmith. I'm going to do a couple of videos around it, or at least maybe point you to specific videos that you can follow to set things up. This has a lot. So depending on what you want to set up. But the first thing, of course, is that you have to build your app and then you connect Langsmith to it. So unfortunately, I don't have a lot of time left. I wanted to run through the last part of, our presentation, which is, or last part of our class for today, which was basically how you can, um, set up a simple, or a more robust backend that has RAG. I've been doing it here a bit, but we don't have much time, so we can do it another time. From next week, we are going to move to front end. From next Friday, from coming Friday, we're going to go look at front end, right? As somebody who's building front end, whether it's a mobile front end or a web front end, what are the things that you want to incorporate into your app? What are design principles? It is very good to have a little knowledge of that. So we are going to look at that. Yeah, that's it from me. Are there any questions? Okay, let me stop recording.